Okay. Upper Chemistry by Apurupa Ghosh. The topic is stereochemistry. Okay. Stereochemistry means the chemistry in space described as a function of molecular geometry. That is, stereochemistry means chemistry in space, that is space oriented, and describe chemistry as a function of molecular geometry. Molecular geometry means, if we consider from Dalton's law, that atom is the most smallest divisible particle of the any element. But we know that when the atoms are combined, they produce bigger molecule. And the molecule, every molecule have their different shape, geometry, and also orientation. So when we see their space, their orientation, and their atom-to-atom connectivity, we can describe the term stereochemistry. And stereochemistry is very vital for organic chemistry. And the basic part, first one, that is isomerism. Now, the question is, what is isomerism? Okay, isomerism means what? That must be the compound which have the same molecular formula but possess different physical and chemical properties are called isomers. That means their molecular formula that should be same but possess different physical and chemical properties are called isomerism. The physical and chemical properties that should be dissimilar, that should be not same. Okay, but their molecular formula that should be same. As for example, we can say that is dimethyl ether and as for example, we can say dimethyl ether and also CH3, CH2OH ethanol. I think that should be there. I think I can say okay. This is ethyl alcohol and dimethyl ether. Molecular formula that should be same. If we consider carbon, 2 carbon, 6 hydrogen, 1 oxygen. There should be 1 oxygen, 6 hydrogen, as well as 2 carbon. The molecular formula that should be same, but their atom-to-atom connectivity that should be defined. There must be 2 methyl group, there must be 1 methyl and 1 CH2 group. There must be 1 oxygen, and there should be 1 OH group. So that is called isomerism. Okay. Okay. Then first one, the types, structural and stereoisomerism. Structural isomerism, that means the isomer that has defined molecular constitution. That should be defined atom-to-atom bonding sequence or atom connectivity, are structural or constitutional isomer. And this phenomenon is known as structural isomerism. That means they are molecular constitution, or that is called atom-to-atom connectivity. As for example, the carbon attached with 2 CH3, 1 H and 1 CH3. There the carbon is attached with 1 CH3, 1 CH to CH3 and 2 hydrogen. So that means the atom connectivity that should be defined. The atom bonding sequence that should be defined. That is called constitutional or structural isomerism. And there must be various types. First one, chain isomerism or nuclear isomerism. Second one, position isomerism. Third one, functional group isomerism. Then metamerism. Then tautomerism. Okay. So chain or nuclear isomerism from term, we can say that is, it indicate the chain. There should be somehow chain is present. Okay. Position isomerism, there must be some position oriented isomerism is found. there must be functional group isomerism. That must be, there must be some defined functional group that should be attached. As for example, ethyl alcohol and dimethyl ether, which are given, there must be one is oxygen attached, other is alcohol is attached, OH, right? And then we can say metamerism. And tautomerism, we can know, many people know that keto-enol tautomerism is general tautomerism. There should be one form is converted to other. Okay. Then we can say the elaborate examples. Okay. First one, chain isomerism. Okay. First one, N-butane, isobutane. N-butane, isobutane have same molecular formula, but arrangement of the carbon atom that should be defined. We know that first one, N-butane, there must be 2 CH3, okay, and 2 CH to methyl group, and there must be 3 CH3 and 1 CH group. There must be no CH is present in here, no CH is present. But here 1 CH is present. Here no CH2 group is present. But here 2 CH2 group is present. So arrangement of the carbon atom that should be defined. Okay. Next we come positional isomerism. That is somehow the position is defined. That is first one propan 1 all. 1 means one position there OH is occupied. Okay. Next one, propan 2 all, that is must be OH occupied in 2 position. If we consider that is 1 carbon, and if we consider this is 2 and this is 3, that must obviously OH is attached to what? 2 position. So position OH that should be varies. Okay. Next one, functional group isomerism. That must be ethyl alcohol and dimethyl ether. That is the molecular formula same, but we can say functional group isomerism. There must be defined function is present. Here OH is present, here ethyl linkage is present. So ethyl linkage and alcohol, that is not same. That is actually defined. Next one, metamerism. Metamerism denoted the due to linking of dissimilar alkyl group to the same polymer atom of the group. That is, the alkyl group is defined. There must be 1 CH group is present, okay, 2 CH group is present, okay, and 1 CH group is present. Here 2 CH group is present, okay, but 2 CH2 group is present. We see here methyl group is present, here N-propyl ether, that is N-propyl group is present, but here isopropyl group is present. So isopropyl and N-propyl that should be not same. They are dissimilar. They are defined. So alkyl group, the character or the nature of the alkyl group that should be defined. That is called metamerism. Okay. Next we come tautomerism. Tautomerism, actually there must be some equilibrium, but that is missing somehow. Okay. But we can say ethyl acetoacid, that is a keto form. There must be 2 COO group is there. 2 keto is present. But here 1 keto is converted to enol. 1 keto group that should be converted to enol. That is called ethyl acetoacid but enol form. There is 2 form, that is both are ethyl acetoacid, but 1 is keto form due to 2 keto groups. Okay. 2 keto groups, and there should be ethyl acetate form because 1 keto group and 1 enol form. In means double bond, here double bond is formed, and 1 all, that is OH. Due to 1 OH and 1 double bond, that is called enol form. Reversibly change one form to other. They should be reversibly changed. That's why keto enol tautomerism that should be very much famous. And we know that there should be some alkylation or many things can be best described by enol form, and also many things best described by keto form. If we study carbonyl compound, we must study both of things. Okay. Next we come. Okay. Stereoisomerism. Next topic. Stereoisomerism, the isomer with similar molecular constitution. Okay, molecular constitution same. That must be atom to atom conductivity almost same. But we define special arrangement of the various atom or groups but about the rigid part of the molecule. Rigid part means asymmetric carbon atom. Asymmetric carbon atom means that is the carbon atom that should be having 4 defined functional groups or 4 defined groups. That is called asymmetric carbon. If carbon is attached with fluorine, chlorine, bromine and hydrogen, then carbon is called as asymmetric. Okay. And double bond. Okay. The isomer with similar molecular constitution but we define special arrangement of the various atoms or groups but about a rigid part of the molecule. The isomer having same molecular constitution, that means atom to atom conductivity that should be same. But there are special arrangement that should be defined. Okay. And that should be about rigid part. Rigid part means asymmetric carbon atom or double bond. Double bond also rigid because there are no restriction of free rotation is there. We know that single bond can be freely rotate. So we can found C stars form, right? But double bond is restricted towards the rotation. Okay, barrier is very high. Okay, symmetry based classification of stereoisomer. Okay, symmetry based. Okay, molecules with same molecular formula, if they are superimposable. Superimposable means if we placed one thing to the other and they should be similar, they are called superimposable. Okay, as for example, we can say that is one molecule that should be replaced the other and they all have same properties. That must be, we can say by model actually. That is, if a ball is put in the other ball, if they have the same, that is called superimposable. That is superimposable. Okay. We have to explain this by model or pictures later. Okay. Then you better understand. Okay. If they are superimposable, yes, then they are called homomers. Or they are not superimposable. Same molecular formula, but if superimposable, they are homomer. That must be they are identical. They are same actually. But if not, they are called isomers. Okay. Same bonding connectivity, jodi if there must be yes, bonding connectivity is same, that is called stereoisomer. If not, constitutional isomer. Okay. If stereoisomer object and mirror image is there, if mirror image is there, object or mirror image, they are mirror image to each other. Suppose A is having the mirror image of B. A and B actually they are mirror image to each other. Then they are called enantiomer. If they are not mirror image to each other, they are called diastereomer. Okay. Classification of stereoisomer based on joint criteria of symmetry. Okay. Stereoisomer, if object and mirror image, if mirror image is present, if they are mirror image to each other, they are called enantiomer. If they are not mirror image to each other, they are called diastereomer. Okay. If enantiomer, there was energy barrier. We know that energy barrier, if high, that is called configuration enantiomer because there was a bond making and bond making is needed. And if low, that is conformational enantiomer. Okay. Then we come diastereomer. If energy barrier if high, that is called configurational diastereomer. If low, that is conformational diastereomer. Conformational diastereomer. Okay. Homomers. Homomer means that is they are same. Actually if we rotate and rotate, they are actually same. They are superimposable. Bromo, fluoro, methane. They are homomer actually. By this picture we can say that is they are not homomer, they are not superimposable, but they are actually superimposable. They are actually identical. Okay. If we rotate, we get same thing. Okay. They are superimposable and identical. Next part, geometrical isomerism. We know cis and trans are geometric isomerism. This is cis and this should be trans. The two groups are opposite to each other, so that is trans. That is trans. Okay. Then we come difference between the configuration and conformation. Configuration, conformation. Okay. That is the term configuration is meant to denote the arrangement of the atoms or groups in space around the rigid or disymmetric part of a molecule. Disymmetric part means the part of a species which contains double bond or a ring structure. Is said to be rigid one. Okay, double bond or ring structure. That should not be free rotation is there. That's why rigid structure. As rotation about them is not at all free. While the disymmetric part, okay, they are basically rigid part. And while the disymmetric part usually possesses chiral atom. Chiral atom means an atom carrying defined single bonded atoms or groups with tetrahedral disposition. Disymmetric part is nothing but that is a chiral atom. Chiral atom means that is defined groups are attached to the carbon. Okay, that is called chiral. That should be called tetrahedral disposition. Okay, so that must be configurations mean to denote the arrangement of the atoms or group space in rigid part or disymmetric part. Maybe rigid part or maybe disymmetric part, the arrangement. That is called configuration. Okay. Rigid part means that is double bond or cyclic part, and disymmetric part means basically chiral carbon. That is having defined groups. Then the term conformation, on the other hand, is used to denote any one of the infinite number of momentary arrangement of the atoms or groups in space, owing to rotation about a single bond. If there is single bond, we know there must be free rotation can be possible, and when single bond rotation is possible, there must be many types of infinite number of momentary arrangement is possible. That is called conformation. There is no need to break or make the bond. That is, the energy there is low. Therefore, a molecule could have an infinite number of conformations because there must be so many arrangements can be possible. However, only one conformation. Oh, sorry, that is configuration. There should be configuration. There must be not conformation. Sorry. Okay. Okay. There must be change from one configuration to another involves breaking and making bond. That's why the energy is high. Change of one configuration to another, not conformation, that is configuration. So we need high barrier of energy because their breaking and making bond is must needed. Okay. So because there must be disymmetric part or rigid part, so free rotation is not possible. So configuration, for the case of configuration, mind it, there must be breaking and making bond, and so that is not possible to one form to other. So every molecule have one configuration but many conformations. Conformations is more than, can be possible more than one, but configuration is basically one. Okay. Okay. Then after that, now that is up to this, but after that we upload many lectures, and there we should describe the other stereochemistry, physical chemistry, chemical kinetics, and all over things, so on. Thank you.